Hello and welcome to this Spirent tutorial. In this particular video, we're going to focus on how you can quickly set up Spirent to do some basic L3 routing through the switch. And so this is going to be if I want to simulate maybe a one-to-one or a one-to-many or many-to-many routed flows between L3 capable clients. And we're also going to show you how we can get some dynamic ARP resolution for each of these. So some of the use cases for this particular flow might be, obviously, if you just need any combination of IPv4 source and desk traffic, maybe you're testing port channel load balancing or something similar, or maybe you just need a large number of ARP entries on the switch. This will be able to do that as well. Or if you just need anything that requires a little bit of dynamic traffic flow within your recreate, this is going to be a good example for you. So we're going to start off. I've got three things here. So I've got my switch over on the left, and we could see I've got no current ARP entries and no entries in the MAC table. I've got my Kalo details here, as well as a VM to control my Spirent ports. And so in this case, I've got 4 ports that have been checked out to me. Spirent ports are usually checked out in pairs. So in this instance, slot 2, port 1 and 2 are paired off, as well as slot 1, port 3 and 4. But I'm going to be using only one interface out of the pair. Normally for you, you'll probably have both of your pairs connected to the recreate. Now, if I go to my VM here, I need to select one of these Spirent test centers. But a challenge often comes up of which one do I want to use. So we can quickly tell which one we want by going to the IP address here. So this is the actual chassis IP of our Spirent test center. I'm going to copy that IP out. And I'm going to paste it up top in the Internet Explorer here, and this is going to pull up the web page for the chassis, and I can see this chassis is using version 4.69. Now, if you don't have that version of Spirent Test Center, or you ever want to download this to your own PC, this is how you do it. You select this link here, but I've already got version 4.69, so I can close this out and double click this. Now, once this Spirent Test Center starts loading, we're going to need to connect to the chassis using that same IP. So if you haven't copied it out already, now would be a good time to do so. And in this particular video, or just in any Spirent training to begin with, it's important to understand the way Spirent works is we'll need to create our endpoints first, and then create the traffic we want to go through them. So looking here, it looks like our Spirent Test Center is now loaded. So the first thing I want to do is I want to close out this window. I really don't want to use any of the quick start guides, and I want to start off here. So the first option I want to First option I want to select is the connect to chassis and reserve ports. And so here I've already got the chassis there, but if you have nothing here, you want to click this connect/create button. And then the first option is to connect to a physical chassis, and you would paste in the IP address of your chassis there. But in this case, I've already done that, so my ports are selectable. So I'm going to open up this chassis, and now I have all the different ports that are available to me. However, I only really am concerned with 4 of them. So here, test center, slot 2, port 1 and 2. So I want to go to slot 2 down here, port 1 and 2. And you'll see once I select port 1, it's automatically going to try to bundle port 2 with it. So we'll see these both change to be reserved. So I'll select both of those, and then I'll hop back up here because my next is slot 1, port 3 and 4. And one thing you may notice, just to help make sure you're connected to the same chassis that you expect, we'll see that some of the CDP information is already populated here. So not only is this port available, but the CDP is spirentdemo.cisco.com port 101, and that is the host name of my switch over on the left. So I know I'm definitely connected to the right interfaces. So I'll select port 3 and 4 and hit OK. What this will do, Spirent will now connect to these interfaces. It'll push on some basic configs that it needs to make them configurable, and then it should finish with everything disappearing as we see. And now I've got 2 interfaces active. So I've got port 1.3 as well as 2.2. So first thing I'm going to need to do is go over to devices, and I need to create the L3 endpoints that I'm going to eventually send my traffic through. So when I select devices, I get this blank page here. You can hit this add button up top, or just right click in a blank space, and I can add devices here. So I want to make sure I select device. And actually, you know what? Let's go ahead and delete that for now because this is the static config. So you want to hit this add button up top. So let's delete that guy. There we go. This brings us through the wizard, which is what we want. So I want to select port 1.3 as well as 2.2 because those are going to be the two endpoints I'm going to be creating. And I could select next. This is going to be a traffic only device. It's simply going to be sending just some basic ARPs for a gateway, and that's it. This is going to be IPv4. Now, in this instance, both my interfaces are configured as access layer ports. So it says switch port access VLAN 10, so I'm not going to be configuring any VLAN headers, but if this was a trunk, this is how you would impose them. Select next. Now I get to say how many devices do I want per port. So the default setting here is set to 1. I'm going to bump that up to 100, and I'm going to modify some of my settings down below. So my starting IP address, I want to set to 10.10.10.2. .1 is going to be my gateway, so we can see that here. And this is going to be a /24. So if I look at my two VLANs, I'm going to be sending traffic between VLAN 10 and 20, which have these IP addresses here. The default TOS setting is to send C0, which I don't want. I'm just going to reset that down to 0. And then I have some modifiers here. So the default behavior is to increment my devices by 1 for the last octet of their IP address. So this means I'll have device 10.10.2.3.4.5, etc. But then when I go step per port, we're only going to shift the first octet by 1. So that'll give me 11.0.0.1, which I don't want. In this case, I want to increase all 3 of these octets by a value of 10. So this is going to be a step. I'm telling Spirent, I want you to increase this value by a minimum of 10. So this would be 10.10.10.10. The next port would be 20.20.20.20. If there was a third interface, it would be 30.30.30.0. Because again, this is sort of a new starting value, and we'll see how this plays out in just a second. So I'll hit OK there. And I want to make sure my launch traffic wizard is selected because once I'm done creating the endpoints, I'm going to want to get into the actual traffic that flows between them. So when I hit next, it'll now take me to the validation page. And if your step was set correctly, this should match the config that you want for the particular interfaces. So I could see here, port 1.3, I'm going to have 100 devices created. Their MAC addresses are all incrementing. They all use the same gateway, and their IP address increments by 1. If I scroll down a little bit further, all right, so we can see right here is where this now changes over. So now port 2, the starting IP is 20.20.20, and that's because I told Spirent I want to add a value of 10 to each one of these addresses. If for some reason it isn't what you expect, you can simply hit the back button, go here, and then you can modify it. So for instance, if I made this a step per port of 20, 10, and 5, so we could see 3 different values, and I hit next, then I scroll over, we could see it now added 20 to the first octet, so it went from 10 to 30. It added 10 to the second octet, so it went from 10 to 20. And then it added 5 to the third octet, so it went from 10 to 15. So that's how you can adjust some of your addressing if you want it set that way. But in this case, I'm going to go back to what I had, which is 10.10.10.0, and hit next. And make sure everything looks good. They're all using that as a gateway. Here they use 20.20.20.1 as a gateway, which is correct. And the IP addresses increment, the MAC addresses increment. I don't have to worry about any duplicate MACs. So this is perfect, so I'm going to go ahead and say finish. That'll now save my endpoints and bring me into the traffic generation wizard. And so for this, I want my traffic to go between ports 1.3 and 2.2, because that's where my endpoints were created. So I'll deselect the other 2 ports. Hit next, and now I need to tell Spirent where do I want this traffic to flow from. Now we only created 2 endpoints, so in this case I could say I want to go from port 1/3 to port 2/2. So another way to do it is to select device 1, 2 device number 2, and we can see it's got the IP ranges there. And I could tell Spirent I want this to be bidirectional, and it could be either 1-to-1 or many-to-many. I'll just go ahead and click the 1-to-1, so this would send from 10-10-10-2 to 20-20-22. It would send 10-10-10-3 to 20-20-23. So it basically gets some basic L3 connectivity between all 100 clients on either side of the link, which is perfect. So now that I have these options selected, I now need to add this flow by hitting the add button. And if you did it correctly, we should now see device 1, and then I have this sort of double ASCII arrow and device 2. If for some reason you screw up, say I only did from device 1 to device 2, and I accidentally made it unidirectional and I added that, you would see I've only got the single ASCII arrow. I could just select that one, remove it, and I can re-add as needed. So in this case, I'll remove both and I'll redo this. So I've got device 1 going to device 2, bidirectional, 1-to-1, hit add, and I should be all set. Now I need to give this stream block a name. This is optional, but it does definitely help. So I could say L3.2.100 because there's going to be 100 clients. If for some reason you want to send a varied array of protocols or QoS values, you could do that here by selecting this option, going into configure, and then adding the values you wanted to iterate over. In this case, I can go to QoS and diffserv, and I could say, all right, I want to send all diffserv 0, and maybe I also want to include maybe 50-50 between diffserv 0 and diffserv 46. You could hit those options. If not, you can unselect them and you don't need to worry about that. It's all optional information. So I also need to say how big are these frames going to be. Do I want it to be fixed, random, increment, decrement, etc.? I'll just do random. Maybe I want to go between 128 and 1450. So not quite hitting 1500, but I want it to be a varied array of different sizes. Select next, and all that stuff is optional. Here I can see the basic IPv4 packet that it'll be sending. Source and dest IPs will be automatically added. If you wanted to add additional headers, say you needed this to be a TCP or UDP flow with a specific port number, you could do that as well by adding headers. So if I said add header, I have lots of different options here. Now these are not going to be intelligent, so if I do TCP, there isn't going to be a three-way handshake between these clients. It would just send TCP traffic with a basic header and really no data or just made up data in the payload. In the default settings here, it'll give me a source and dest L4 port of 1024. You could double click these to modify them. So I could say maybe source port of 5000. It'll automatically figure out your checksums. But this is just generic flows. There's no intelligence here, no three-way handshake, etc. So keep that in mind. Otherwise, if you need three-way handshakes, take a look at some of the advanced videos that are in this series. So now I want to select next, and I'll just say, yep, TCP is great. And now I have some options. I can generate this in a per port or per stream block. So the way this works is this whole process can be repeated to create multiple different unique traffic flows. If I do port-based, then it means with this setting here, all these flows, whether I have 1 or 100 of these, collectively will never consume more than 10% of the interface traffic. If I select load per stream block, I can now get a little more advanced. So maybe I can send, if I want to create one flow that was nothing but DSCP46, maybe I can send that at a rate of 5% of the interface speed, versus another one that's, say, DSCP0, I can send that at 40% of the interface speed. So this allows multiple flows to have different load values associated with them. So I prefer to use the load per stream block just automatically. It's a little bit easier to add after the fact if you ever want to add more flows. So click that option. And my load mode here, I could do fixed. There are other options, such as if I want to iterate through a list of different speeds, increment, decrement, or just shuffle randomly, I'll just select the fixed, and I want this to be in frames per second. And so to start off, I want to send maybe 5,000 frames per second in this flow. So with all my options selected, I'll now hit next, and I need to tell Spirent what interfaces will be receiving this traffic so it knows how to calculate the various counters and other stream data information on the back end. So I've got port 13 and 22, so I'm going to add both of those because they will both be generating and receiving this flow. That's very important, is to receive. and I'll hit finish. Now, at this point, my endpoints should be created as well as the flow I'm looking to send. So I can hop over to the traffic generator and I can see the wizard that I just completed now created this particular flow for me. And the status has this gray icon. By default, we don't have any sort of ARP enabled for our switch. So I need to tell, or excuse me, not exit, tell Spirent that I wanted to ARP out. So I could right click this flow and let's see, there we go. And I can do under ARP/ND for ARP and neighbor discovery. I can now do the start ARP ND on all stream blocks. And so what should now happen is it'll switch over to the traffic generation phase. It'll push some programming. It'll create the 100 some odd endpoints on either interface. So that's what it's doing now. It's pushing those down. It's also giving me some interface statistics here. And it should, we can see in the total TX count frames, it transmitted 100 frames, received a little over 100 back. So that was all the ARP requests. Each client was ARPing for its gateway, and it got a response. And if all of your clients are able to ARP successfully, this status should turn green. If they did not ARP successfully, then this will go into a yellow color. So if I go over to port 2, because I did all stream blocks, we can see this also turned green, but it's always good because now this one is ready to transmit, but I want to make sure I ARP on this side as well. So I want to start ARP ND, and we'll see here on port 2, it now ARPed out. It sent 100 frames out. It got over 100 in response. And if I look at my switch and I look at show IP ARP, all right, so the switch did not populate anything, but there should be some MAC addresses. Let's make sure those are there. Yep, there we go. So now the switch is actively learning the MAC addresses from these clients. They all ARPed out for their gateway, got a response, so we learn the MAC address, and they'll be ready to start sending traffic. So if I go over to my traffic generator, and I can do this on either port first, I can now right-click this and hit start. And what I should see for my total TX rate here, this is scrollable. It's fairly large. If I want to go over to the port counters, that's going to be closer to the end, so I can see my total TX rate in frames per second is currently about 5,000. And it looks like the destination is not necessarily receiving anything. So I'm going to go ahead and go over to the traffic generator here. Right-click this and see if this works in the reverse direction as well. And I can see now both of these are sending approximately 5,000 a second, but they are not receiving any traffic. So if I look at my switch and I look at show IP ARP, I can see there is no ARP resolved still. So let's do IP routing. Let's enable that. And I'll pop back over to my traffic generator, see if that changes anything. And sure enough, I could see the counts are now incrementing as I start ARPing out for these endpoints. It takes a little bit with the glean. But if I look at the show IP ARP, there we go. I've now got lots of different dynamic ARP entries created, and these are all actively sending traffic between one another. If I look at show interface VLAN 10, I can see under the SVI, I'm actively routing and switching traffic both in and out of VLAN 10 and 20 because this flow is bidirectional. I started it on both sides. If for some reason I need to change one of the settings, say instead of sending 5,000 frames, I want this to be 50,000. You can right-click your stream and edit it. And you could change some of your settings. So in this case, I can change things like frame size. You may be able to modify some of your source and destinations depending on what order you configured them in. Or if I want to modify certain aspects of the frame, I could do that as well. But I'm going to hop back over to general. And so for my frames per second, I'm going to add a 0. So it goes from 5,000 to 50,000. And I'll hit OK. And we can see on the background here, the load now changed to 50,000. But if I look at the way it's currently working, it still sends 5,000 a second. So this is one difference between IXIA and Spirent. With Spirent, any changes you make do not automatically get applied. If this was IXIA, within 10 seconds, this change would be applied and automatically take place. So in order for this new change to be integrated into the flow, I simply need to right-click, I need to stop my flow, and then restart it. So I've stopped it. Now I could start it, and I should see the new TX rate here will now go from 5,000, it'll now go up to 50,000 packets a second. And sure enough, TX and RX are both approximately the same values, so I know the switch is actively forwarding traffic for these clients. And that is going to be the end of the basic L3 demo with ARP resolution using Spirent. I hope you found this video useful, and feel free to check out some of our more advanced video topics. Thank you and have a good day.